right, so before in the example, you were given the parts of the one formula, and the next one you were given them as a coordinate. This is a situation where if you had to find the angle, those are the three cases that you'll have. And so now, if you want to go and you're working at home, you want to look at these two examples to see where that would happen. So we're going to do an example of where you have to find the theta. So give me any vectors. We're going to call it P and Q, and give me numbers. All right, so in our formula is cos theta. And remember, you don't have to memorize this. It's the same as the initial step. You would just have to divide over. But you'd have P dot Q over the magnitude of P times the magnitude of Q. So to start, to find P dot Q, let's multiply our x's together. So we have 1 times 3 plus negative 2 times 99. Yep, so it'd be negative 195. So that's the first part. Now we want to find the magnitude of P. If we're looking for the magnitude of P, so your Pythagorean theorem would be the square root of 1 squared plus negative 2 squared. So you have square root of 5. So that would be the magnitude of Q. And now we just plug them in. Now for accuracy, what I would recommend is don't type this in, get a decimal, and then only keep a few decimals. I would, if you can, and you have a good calculator, like a Texas Instrument, you should be able to do cos inverse of the entire side. And that's what you get for theta. So what a projection is, it's a shadow. So if we're projecting V onto U, if this is going to cast a shadow, so we have light, we have the sun, something beaming down on this vector V, the shadow of this will be right there. Now, this is only the case when our theta is between 0 and 90. So if you had to find the magnitude of this dotted line, this shadow right here, the formula that you would use would be, you have your projection of V onto U, and you're finding the magnitude. It will be the magnitude of V times cos theta. Now what if our angle was between between 90 and 180? So that would be this case here. Our theta is bigger. If you were to shine light down on V, where would the projection, bless you, where would the projection or the shadow be? The shadow will be that way. What is the direction of the projection? It's the opposite of U. So if we put light on this down and you create a shadow, there is no shadow, and that's why you get the 0 vector. So all the other formulas I gave you before were going to be how long the shadow was going to be, or how long the projection. This is your formula for what is the actual vector location. So if you do that projection, where does the head of your vector end? And where does the vector come from? It's this. This you actually sub in the vector, and then the beginning part will be a scalar. The difference between these two, here you're given the angle, here you just have to find the dot product. So it's more that you'd be given the Cartesian coordinates of the vector. But both formulas will find you the coordinates of the projection of the vector. All right, so in here we are given an angle. What is our angle? 50. Is that within which range? Between 0 and 90 or 90 and 180? Okay, so we're going to use that formula then. If we're doing projection of U onto V, this is the magnitude of V cos theta, because our theta is between 0 and 90. And so if we plug in the values, oh wait, sorry, hold on. So sorry, that should be U. And so you have 5 times cos of 50. And what do you get? Okay, so for the next one, what range is this angle between? Between the 90 to 180. So our equation for the projection of P onto Q is the magnitude of P, the negative magnitude, and then cos theta, because it's the opposite direction. So if we substitute in values, we have negative 20 cos of 120, and what do we get? So we're going to use the second equation to find the projection. So this is the projection of D onto C, which equals D dot C over C dot C, and then times it by the vector C. So that's what you would have for the first step. So we take that negative 10 over 17 and you distribute it through. So your vector ends up as the following. And that would be the location of the projection of this vector. So if this is just the position, would it be possible for you to find the magnitude of this vector? You would just use your regular Pythagorean method, with this being a position vector. So you do the square of this plus the square of this, take the square root. So you wouldn't have to go back to the other formula because we already just found the vector.